I, for one, welcome our new debugging overlords. I'm Ray Myers, and welcome to Craft versus Cruft. And here with us, we have a guest, Kyle Forster. Would you introduce yourself?
All right. Thank you so much for having me on. My name's Kyle Forster. I'm currently the founder of RunWhen. We're working on troubleshooting AI. Before this, I was at Google. I was on the Kubernetes team there. And this, in many ways, grew out of some ideas that we worked on back at the old shop.
Great. Now, my most recent episode is actually me talking to a language model about the notion of resilience and using as an example Kubernetes. So I thought it was just awesome when someone from your group reached out after that. That's okay. You're actually doing a very real thing of the joke that I'm telling. About what, specifically managing Kubernetes, but also like what elements of owning this come from machines well and what parts come from humans well. And I found that we had a lot of similar ideas. How do we use this the right way and not in like a catastrophic way? So I think this will be a really interesting conversation. There's no kind of paid endorsement thing happening, but you can certainly learn more about RunWhen in the description. And tell us a little bit about what it does and why you decided that you wanted to build it.
Sure. I mean, the genesis story happened when we just saw so many teams that were getting stuck with Kubernetes. And I spent a lot of time looking at this, and maybe because when it's kind of our product, the issue is we felt less Kubernetes itself and more, they're about, give or take, around 800 open source packages that represent about 70% of the Kubernetes workloads worldwide. 800 open source packages is a lot. I mean, the average small team already has 40 of them installed, and larger teams have hundreds. And so if you picture yourself as a platform engineer, as an SRE, on the DevOps team that's sitting there, not only do you have to be able to troubleshoot your own team's code and figure out what's going on in both dev and prod, but then there are somewhere between 40 and a couple hundred open source packages in addition to Kubernetes that you're responsible for. And that's where I thought things got really, really interesting. I mean, you start to hit, I think, the limit of what one person on call can do really, really, really fast. And you start to get into, okay, well, it suddenly takes like 2 years to get up to speed on a new tech stack when you start a new job. It felt like there must be some better way. There's had to be some better way. Mm-hmm. And that answer became, after many iterations, that answer became the seeds of RunWhen.
So these iterations, what do some of the less mature options look like? So it sounded like you didn't just go right to this. So what didn't work?
Well, why don't we start on the AI side? Mm-hmm. Because obviously it's topical, and I'm guessing that a lot of the people listening to this would be most interested in, at least from our experiments, what really worked with AI for troubleshooting, but more interesting, what really didn't. The first was getting modern AI, I call it LLMs, plus. Getting modern AI to write troubleshooting commands just didn't work. It just flat out didn't work. The hallucinations, which with code aren't too bad because it's sort of naturally human readable, as soon as you start dealing with lots of command line flags, those hallucinations got really bad. The hallucinations also were really hard to spot. I think when you ask an LLM to help you write 20 or 40 or 50 or 100 lines of code, you can kind of spot where it went off track pretty easily, and a human can. When you ask it to write things that look more like bash scripts with lots and lots of flags, which is kind of typical of troubleshooting, in Kubernetes world, it's really hard for a human to spot where it went off track without actually rigging up a full test bed and doing a full recreate and then trying it. And by the time you do that, an expert probably could have written this thing a lot faster. So we just found, unlike writing Python or JavaScript or Golang, the languages that we use for most of our backend, we're heavy users actually of kind of pair programming with AI. For troubleshooting, it just didn't work. Once an expert had written a basic troubleshooting script, we found that LLMs were really, really good at generating enough metadata around it to create very high quality search. Like not slightly higher quality, like incredibly high quality search. So that's what started to get us into it. We actually started using this for our search engine. We found along the way using things like LangChain plus OpenAI, LangChain plus Bard, building the chatbot interfaces up front. They didn't work particularly, at least I didn't find them particularly compelling. We were joking around that, I was using a chatbot to try to cancel my subscription with my ISP. I recently made, and the best that chatbot can do is point me to a web page where I can schedule a call with a sales rep to try to cancel my subscription. If there are no capabilities on the back end, the fact that it can apologize to me in natural language isn't that great. I just want to cancel my subscription. So I think why, I'm straying really far from your question, but I think the reason that ChatGPT caught the world by such storm was not the natural language interface. I think that's an interesting part, but the fact that it was running all these really interesting, effectively web searches on the back end and coming back and summarizing what it found. And so we rapidly found it wasn't actually the natural language part. It was the incredibly awesome search engine that we could build on top of this. And the search interface, it was really interesting.
So there's a lot that's been done with search already, like a lot of which used to be part of AI and is now what we expect a search engine to do. Because AI is kind of a, moving target for whatever the most sophisticated programs we are learning how to write are. Why not just use a search engine like Lucene, Elasticsearch kind of thing? Like why are LLMs helping you get better search?
So, let's not forget that a huge amount of the research that sits underneath LLMs was built for search engines. Now, not for the Lucene kind of branch of search where we think about, hey, you have a document and you're trying to cut that document up in many ways to index it very, very efficiently. That, I think, search kind of hit its limits 10 years ago. And building a good search engine that way is kind of well known. But it's still quite expensive to make a high-quality search engine. The spot where LLMs do incredibly well is where you take a document and you say, all right, what's the intent of this document? Or you take a row in a database and you give it a little extra context and say, okay, so what's the intent of this? Or you take a snippet of code, you say, okay, so what was the intent of this snippet of code? And you add whatever extra context you can. LLMs are incredibly good at then summarizing the intent of that area. Even if you actually don't show that text to the end user, when an end user actually puts in a search query, you can also give an LLM a whole bunch of, hey, here's the search query, but here's a whole bunch of other interesting information that we have about this person and what they're doing and their last 5 searches, et cetera, et cetera. So we can try to figure out the intent of their search. And on the other side, we can try to figure out the intent of all of the things that could be searched. And then you match those. So the beauty that LLMs do is they bring in a lot of information that wasn't actually in the code snippet. They bring a ton of words that were never there in the first place, but are quite relevant.
So if you've got this better search engine, now is that something that is sort of custom built for your use case? Or, is that something, maybe in 5 years you end up pivoting to, it's RunWhen instead of RunWhen or whatever, it's this sort of this general knowledge grappling engine.
I think this, having been across companies I've looked at over the last 20 years, this is now actually the 5th search engine that I've been a part of. And I will say this one is, I think building a high-grade search engine is about 1/10,000th the cost this year that it was last year, thanks to LLMs.
Yeah.
I think I do not think that the lasting impact of modern AI is going to be chatbots. I think so many people are going to build really crummy chatbots that have great natural language and really bad capabilities. That I think there's going to be a big backlash in the industry as a bunch of users use these and go like, wow, another really dumb chatbot that doesn't do what I wanted to do, that can't even cancel my subscription.
Uh-huh.
I think we'll see a big backlash against that come around, basically around the end of the year and first half next, as a lot of major vendors do their V1s. I think the really long-lasting thing will be, hey, we're starting to use search in a lot of enterprise product interfaces. And the search will be increasingly specialized. When we think of search today, we think of searching web pages, but it'll look like searching database rows. It'll look like searching code. It'll even look like searching online functions, which is sort of what we do as core to the product. And that to me is where things get really, really interesting. You also have to think, there are a lot of technologies. A recommendation engine is just search. It really is. It's just a couple of different inputs. You don't ask the user for a query, you grab the inputs from somewhere else. If you look at the top 5 e-commerce sites in the world that can afford to build their own search engines and can afford to build their own recommendation engines on top of that search, about 70 to 80% of their sales come between search and recommendation. But nobody beyond the really, really big ones can afford to build these things. So I think search will show up in search will show up in recommendations, and the technology also sits underneath digital assistants. I mean, a digital assistant is a search for a function that I can do it, take the output of that, run another search. Okay, let's see what a function does. Let's take the output of that and then run another search. I don't think that the natural language part is anywhere near as important as having a really intelligent digital assistant that just, in our case, took 5 troubleshooting steps, each one saying like, well, given the output here, I'm going to do this next for troubleshooting. Given the output there, I'm going to do that next. I think that those will be some of the big impacts, not the chatbots.
Yeah, so it seems like you're looking at this integration with AI into your product in a very different way than a lot of people are talking right now, because you got people saying, hey, in 5 years we won't even write code. And you're saying you can't even get this thing to reliably write a debugging command. Once the rubber meets the road, it's bad at troubleshooting. Well, good luck trying to, develop a large application without doing any troubleshooting, right? But and then also the other part of it is like, everyone's really excited that it can talk to you, which is great. A lot of things that we couldn't do before with that, but you don't simply just drop a chatbot in front of your user and dust your hands and say, I guess I don't need a user experience now, because it turns out that it's an impressive but very useless user experience so much of the time, right? You still have to reason about what are the actual paths you want to let people go down. So it sounds like then you've got scripts that are written by experts and you just have a library of them, and you've recognized that AI can help you select which ones you want to run and how. And then you present those to the user as options. Like, you're not really showing them the output of the LLM so much as, some options that it is, come up with in the combination with the rest of your search machinery. Is that right?
The wonderful thing about it, you can take something that looks like, okay, both user query. Oh, hey, pods are down over here, or hey, my pod won't start. You can also take a lot of other information about the environment that you have that's currently live and bake it into the query. You can say, well, somebody's saying pods are down, but we also just noticed an interesting event that's happened that has to do with persistent volume claims. So let's just add that to the user's query. The exact same way Google adds your current location to the query.
Okay,
why so search restaurants? We'll find a bunch of restaurants right next to you.
Yes, so I could have a bunch of Runbooks on the wiki right now, as I probably do. And it could also be the case that over here in PagerDuty or Opsgenie, what have you, there's a lot of information about what's happening now in the system, and therefore which ones of potentially hundreds of Runbooks I might want to be interested in right now. But never when I search Confluence Wiki does it take any of that into account. Right. So you're talking about joining knowledge sources, into a search experience that wouldn't have been done before.
For us, modern AI was so good at taking the output of one troubleshooting command and then finding the right one to run next, and then taking that output and finding the right one to run next. I think the end of Runbooks is ahead. There's just no need to write a full Runbook. You write lots and lots and lots of little steps. Or in our particular case, have an expert community outside your company write literally thousands of little steps. And then as a user, you'll say, all right, hey, here's a problem. Give a rough description of a problem. And then have your AI digital assistant say, okay, well, here's where I'm going to start. And then given on that output, here's where I'm going to go next, and I'm going to go next, and I'm going to go next. And I don't think that you'll write these like incredibly fragile 10 or 15 step run books that seem to be aged out before you're even finished writing them. But these things will just be thrown together dynamically on the fly. I think it really changes the way we think about automation. Like I think a lot of SRE and DevOps automation will become these very, 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 very small troubleshooting steps, but a gigantic palette of them, some written by your company, some written by a lot of experts around you. And they're thrown together as needed and on the fly. I noticed like when we refactor our own microservices internally, we don't actually change any of the configuration for our equivalent of runbooks. Since the AI can string them together, our configs don't change. The stuff just still kind of works. It drops out the steps that don't work or that are no longer relevant and adds a whole bunch of new steps because it just finds them.
Whereas the cost of a bad output, if you're just letting it construct and run totally arbitrary code, is pretty high. Like there's a lot of risk there. But if you have a bunch of steps that you've vetted, like these things should all be safe to run. They should, at worst produce no information, but they're not going to be destructive. You can pretty much, say, okay, go nuts machine, put these in whatever order you want. Like, and the worst thing you're going to do is waste a little bit of time. Like kind of reminds me of the shift towards automation that was more state oriented, like Ansible and like Terraform, where we have a goal state and we have all these little bits that we can assemble that have very predictable results. And as long as you're building on a foundation of pieces that, the behavior is pretty well understood, a good euphemism for bad automation I've seen is from Sorcerer's Apprentice, where Mickey Mouse is like, trying to carry the water and creates, all these different brooms that you just go out of control. If you have pieces that are safe to use, you will generally build something safe out of them.
Having just spent time on the Kubernetes team, the declarative programming pattern was sort of drilled into you like this: thou shalt be declarative, thou shalt not be imperative anymore. Yes, these state reconciliation patterns, I think for automation in general, were a huge step forward. I think with the advent of modern AI, I think we're going to see a new pattern emerge. Troubleshooting, especially. Not for deployment, but for specifically for troubleshooting.
I think it's an underrated part of the process. I mean, on my website, mender.ai, I think one of the first taglines is the future of software is the future of software maintenance.
I think actually one of my colleagues copied and pasted that actually into our site.
Beautiful. That's what I like to hear. Let me sidetrack you though, because and I'll pin it right on you since you were, I think you said a product manager, working on Kubernetes, not just the way I do, which is as a user of it, but you were on a team that develops Kubernetes. Hey, aren't you just now building a bunch of glue because Kubernetes is way too difficult and complicated? Like, did we all just go wrong here? And we're just trying to plug the gaps of complexity that the industry has created. I mean, why is this so hard?
This is kind of where back to the start of our conversation. If I felt like the answer was Kubernetes itself, I would have stayed on the Kubernetes team and tried to solve it by advancing the state of Kubernetes. I don't think it is. I think that the really hard parts about troubleshooting Kubernetes are this massive ecosystem of open source projects and vendor projects now that we have running on top. And the troubleshooting challenge isn't troubleshooting the Kubernetes platform. It's like, why did Nginx do this? Why did Kafka do that? Why did Postgres, when running under Crunchy, do this other thing? You start to need to know not only Kubernetes, but you need to know so many of these different open source projects to really make practical progress when troubleshooting. And you need to know so much about how they interact with the Kubernetes platform, which is interesting, but you also need to know so much about how they interact with their own just straight disk and memory and I/O and how they interact with all the other programs around them, that I don't think that it's bounded to a single software framework or a single engineering team that can solve the Kubernetes troubleshooting challenge. I think it's many, many, many hundreds of teams. In fact, I think you have to get 800 teams together to make progress on just 80% of the problem.
So their setups are so diverse. This has been a challenge historically for any vendor to say, I'm going to give you, you know, this tool that was developed completely independently of your company, to be able to give you insight on the unique terrain that you've got. Obviously, you're hoping that you'll have better results than a lot of them have, especially in the AI ops space. I think there have been a lot of disappointing results even before this new AI boom. So a lot of people may be wondering, are we just going to have more than the same with AI ops? But part of me also thinks that just the existence of Kubernetes, like even though it exists within all these disparate contexts, provides some kind of connective tissue. Like at least there is one common vocabulary at the core that like we can branch out from. So what are your thoughts on that? Like, are you starting with Kubernetes just because it's like a very popular technology, or do you think there's something unique about it that makes it more tractable to, do this more general diagnostics in all these different companies?
I think there are two thoughts on that, and they kind of branch in somewhat opposite directions. But we had this snarky slide for fundraising where I said, we asked ChatGPT, how do you troubleshoot Kafka on VMs? And then we said, okay, how do you troubleshoot Kafka on Kubernetes? And we just underlined and highlighted the two parts where, hey, okay, this requires serious systems integration. This requires serious systems integration. This might require custom code for every client. This certainly requires custom something for every client. And then on the other one, we had like one thing outlined. And that was it. And we're like, look, this is not us. This is, and we repeated the thing 5 or 6 different open source packages. So the sheer number of systems integration projects that are required to troubleshoot Kafka or Postgres or Nginx or Cert Manager, like inside the Kubernetes itself, I think there's kind of a more bounded set, and that makes these things go a lot faster. If you have to do like 4 major systems integration projects, people just get tired before the thing's shown any benefit. And on a Kubernetes, you just give it a kube config and that's it. However, I'm very, very, very pessimistic that like one AI algorithm can troubleshoot all of these different open source packages. We structure the company and the business model with this idea of, we call them the RunWhen authors that contribute troubleshooting commands and small troubleshooting scripts that are slightly optimized for our AI discovery. And then what customer pays us, we actually pay them a royalty. It's a paid open source community. I can get into why I think that's fair. I mean, I think we have a really interesting, I think the future of open source is actually paying the contributors rather than just expecting people to do it out of the goodness of their hearts. We structured it simply because I think that it will take hundreds and thousands of experts all chipping in little bits and pieces, little bits of things that they learned from, gosh, I spent 2 years of my life trying to make this thing work. And finally, here are the 80 or here are the 100 troubleshooting steps that I think really, really worked well. Oh, I spent a year and a half. Oh, I spent 6 months just doing battle with this thing. And here are my favorite troubleshooting commands. And getting hundreds and hundreds of DevOps, SRE, PEs to contribute those, I think that makes the difference much more than any one algorithm. So we structured the company specifically with that in mind and with the idea that we're going to pay people for their contributions in this front.
I hope for that future as well, where there's this, this avenue for people to just, fill in the gaps and, get paid for it enough that'll be worth their while. It's hard to chip off consulting work into really small blocks like that. So yeah. It'll be, I'll be interested to see how well that works, if that's a model other places are able to copy. And especially if you're talking about getting, DevOps engineer time as well, like that is pretty highly valued time.
I think that it's a little bit like watching something like GitHub Copilot take code that a lot of people have written and then turn that into a recommendation for somebody else. Mm-hmm. I do. Some part of me says, hey, the fair thing would be to actually, if you're going to charge for GitHub Copilot, then you should pay the people whose code you just recommended to some new person.
Can't argue with that. There's a whole can of worms with the impact that this might have on, copyright protections. And I think people are seeing that, like, oh yeah, if you're an individual, you're expected to follow copyright if you're profiting. But if you're a megacorp scraping the entire internet, then apparently it's all for the love of the game. Who are these protections really protecting, and who do they not restrict? You're doing something that allows you to say, like, we're curating a custom library for this purpose, and we can pay for these targeted things to go in our library. That may turn out to be a more common model.
There's a whole nother conversation there about how I think that actually the consumer internet will change with AI, but that's out of scope, right? I think what we care here is building really interesting search and recommendation and digital assistants that are looking out for the information provided by a very, very specific community of experts. That's incredibly, I think, this incredibly high value IP that they're contributing, and it's incredibly high value IP that any of our users would be consuming. Hey, I want to troubleshoot Redis. Redis is down. Okay, well, here are 30 steps to troubleshoot Redis. Do you want me to run the first 5 and then see which one to run next? Yes. I think that's so much value on both sides that it's an easier argument than the consumer internet. The stuff that's going to be a lot more complicated.
Yeah. So taking it back to team dynamic, then, like, once you have that, how does the way people are engaging, every topology is different, but, in a typical case that you'd imagine in a medium to large organization, like, how has life changed because you had this? What was happening before that isn't happening now?
So at least what I saw, certainly in my last serving platform teams, and before I spent the earlier part of my career in networking, and certainly you see it as a networking teams, there's kind of this like guilty until proven innocent thing of, hey, I'm an app developer. My code is doing something different today than it did yesterday. It must be the platform is broken. And the first thing that I do, or pretty close to the first thing that I do, is find the most senior person on the platform team that I can and hit them up over Slack and say, hey, my code is doing something different today than it was doing an hour ago or than it was doing yesterday. I think it's your problem now. It's just a pattern that, I call like part of the human condition. And I think suddenly there's like 3 personas at play. There's the person who needs help. There's the expert providing the help, usually somebody on, I call it like DevOps, SRE, PE team is providing the help. And then there's their team, call it the platform team that they're coming from. And the person usually steps in and is a hero. Hey, let me troubleshoot your stuff. When we do like interviews and surveys, call it 50 to 70% of the time, the problem was never actually the platform. It was either that person's code or that person's setup or maybe some other service that person was dependent on. But let's look at a couple things. In the moment, the app developer says, oh, wow, thank you so much. You're a hero. And it feels great. They also come out saying, why was this thing so damn complicated that I couldn't have done any troubleshooting myself? The platform is too complicated. And it's not the fault of the hero that just helped me out, but it's kind of the fault of their team. And you wind up with this really funny social dynamic where somebody needs help, they're frustrated, they're annoyed, somebody from the team steps in, it's a hero. That hero perceives that they really helped, and everybody has one moment of celebration. The hero kind of recedes a little bit in the background, and the person leaves thinking, gosh, that team really just overcomplicated the problem because I should have just been able to do all of this myself. I think it's actually a really, really tricky social dynamic that is innately human. But insert AI into the mix, and I think a couple things get really interesting. First of all, somebody's frustrated, like something's not working. They need some help, and there's like a 24/7 on digital assistant who's there to help instantly. Like, this isn't like, I'm going to wait until the shop opens. This is like, I'm buying something on Amazon, and I'm just hitting buy right this minute. And I think that really changes, I think that changes the perception of, call it, I don't know, I hear more and more people call it like the SRE help desk or the platform help desk, the platform service desk, a couple of different words. But I think that like, hey, 24/7 always on really changes the perception of how effective this function that's the part of what the team has to provide can do. I also think once you get in the habit of the entire platform team kind of contributing to training these digital assistants. Like, hey, yes, given that issue, you suggested the right couple of tasks to run, thumbs up. Given that issue, yeah, thumbs up. And they're contributing to the training of these things. Then suddenly when they're successful, the app developer walks away saying, oh, wow, okay, I just got help instantly. I didn't have to wait for even 5 minutes for the person to help. And beyond that, the help that I got instantly was the help that I just got from the entire team. I think you start to get away from like, man, that team just made things so complicated that I had to get the most senior engineer of the team to help get me unsnarled. I think you can create a lot more heroes this way in what was a social dynamic that created sometimes one hero and caused people to dump on the entire team 5 minutes later. And I think this way you can make a whole team of heroes out of the platform team.
All right. Well, we'll see how that works out. It's certainly something we'd like to do. So we usually end with a quote. I have one that I always use, but is there any quote you'd like to end on?
I think since we're talking a lot about troubleshooting, there's this one. I know you like quotes from Tao Te Ching. I've been your other shows where you end there. I like this one. Failure is an opportunity. If you blame someone else, there is no end to the blame. And particularly apropos of where we just ended.
Excellent. And as Lao Tzu also said, with patience, the most tangled cord may be undone. Thank you, Kyle.
Thank you, Ray.